Jacobian of functions. In the Jacobian of implicit functions, if suppose f1 u v w xyz equal to 0, f2 u v w xyz equal to 0, f3 u v w xyz equal to 0 are implicit functions of u v w with respect to xyz. These are implicit functions of. Then we have to write Jacobian of u v w with respect to xyz is equal to -1 cube, because there are 3 dependent and 3 independent variables. Jacobian of f1, f2, f3 with respect to xyz divided by Jacobian of f1, f2, f3 with respect to u v w. This is the definition. This is the concept of Jacobian of implicit functions, you may say. Now we'll go to the one or two examples. First one is, if u v w are roots of the equation in lambda, that is lambda minus x cube plus lambda minus y cube plus lambda minus z cube equal to 0, find Jacobian of u v w with respect to xyz. Now first of all, what we have to do? First of all, we have to consider first thing as, suppose a lambda cube plus b lambda square plus c lambda plus d equal to 0 is the equation after simplification. Then we have to make use of properties of roots of this equation, and roots are given as u v w. Then sum of roots u plus v plus w equal to minus b by a. Product of two roots u v plus v w plus w u equal to c by a, and a whole product u v w equal to minus d by a. This is the property of cubic equation, and we will make use of this. First of all, we have to simplify this equation as, you can see that if you solve this, we get 3 lambda cube minus 3, what will be? What will be the equation? Second term, minus 3a lambda minus 3 lambda square x, here minus 3 lambda y square, means x plus y plus z lambda square is there, plus 3 times, third term will be 3x square lambda, 3y square lambda, 3z square lambda, that is plus 3 x square plus y square plus z square lambda minus x cube here, y cube here, and here z cube. X cube plus y cube plus z cube equal to 0. After simplifying this given equation and writing that, and therefore we can see that a is equal to 3, b equal to minus 3 times x plus y plus z, c equal to 3 x square plus y square plus z square, and d equal to x cube plus y cube plus z cube. Hence, by substituting here in this equation, we will get the equations as, what will be these equations? First is u plus v plus w equal to minus b by a, but b is minus 3 times x plus y plus z divided by 3, and therefore it will be x plus y plus z. Call this as equation number 2. Similarly, uv plus vw plus wu equals to c by a, therefore 3 by 3, and that therefore it is x square plus y square plus z square. Call this as equation number 3, and uvw equal to minus d by a, sorry, d should be minus, and therefore we can write d minus d as, and therefore it is 1 by 3 x cube plus y cube plus z cube. X cube plus y cube plus z cube is there, or we can write these equations in implicit form. We will call this as f1 equal to u plus v plus w minus x minus y minus z equal to 0. f2 equal to uv plus vw plus wu minus x square minus y square minus z square equal to 0, and f3 equals to 3uvw minus x cube minus y cube minus z cube equals to 0. These are three implicit functions which we require. We call this as 3, etc. Fourth. Now, first of all, we find Jacobian with respect to x, y, z. Jacobian of f1, f2, f3 with respect to x, y, z. And this is the determinant. Derivative of f1 with respect to x, y, z, minus 1, minus 1, minus 1. Derivative with respect to x is minus 1, derivative with respect to y is minus 1, derivative with respect to z is minus 1. f2 is minus 2x, minus 2y, minus 2z. And f3 minus 2x square, minus 2y square, minus 2, sorry, x cube so derivative of 3 and 3 square is there. That gives you minus 6 times 1 1 1 x y z x square y square z square. Now we have to solve this determinant as we can make use of even properties of determinant also. Minus 6 times you can subtract C1 from C2 and C3. Therefore 1 x square, 0 y minus x, y square minus x square, 0 z minus x, z square minus x square, so that it becomes simple to evaluate. How we can evaluate? This as 1 into y minus x, z minus x, y minus x, z minus x. आत काय राहील बघा, y minus x, z minus x into bracket. इथला राहील z plus x minus इथला राहील y plus x plus y, and therefore minus y minus z minus x. X get cancel, z minus y, and we get minus 6 times 1. We get this as, you may call numerator as 2 minus 6 times, that 6 is there, y minus x, z minus x, and z minus y. That can be written as minus 6 times x minus y, y minus z, and z minus x. फर्दर rhyming. काय केलं याच्यातलं मी, याच्यातलं एक मायनस साईन कॉमन काढला आणि यातलं एक मायनस साईन यातलं एक मायनस साईन काढला आणि हा मायनस ॲज इट इज. therefore we get minus into minus plus, and we get x minus y, y minus z, z minus x. This is numerators, Jacobian. Now we have to try for Jacobian of denominator. For the Jacobian of denominator, what will be that? Therefore Jacobian of f1, f2, f3, Jacobian of f1, f2, f3 with respect to u, v, w. With respect to u, v, w equals to f1 1 1 1. Derivative of f1 with respect to u is 1, with respect to v is 1, w with respect to w is 1. Now derivative of f2 with respect to u is v and w, means here we get v plus w. For derivative with respect to v, u plus w. For derivative with respect to w, v plus u. Now derivative of f3 with respect to e is 3uv, vw. Derivative with respect to v is 3uw, and derivative with respect to w is 3uv. I can take 3 in common from last row, and we'll use the same trick. 1 v plus w, vw. Now subtract c2 from c1, 0 0. What happens here? That becomes u minus v. Now here v get cancelled, u minus w. Now what happens here? Here also subtracting, you can take w common, w into u minus v, and here v common, v into u minus w. You can write this as, आता सेकंड कॉलम मधनं काय करा, u मायनस व्ही कॉमन काढा. 3u मायनस व्ही. थर्ड कॉलम मधनं u मायनस डब्ल्यू कॉमन काढा. इंटू ब्रॅकेट व्हॉट हॅपन्स 1 0 0 व्ही प्लस डब्ल्यू 1 1 व्ही डब्ल्यू. इथं राहिला डब्ल्यू आणि इथं राहिला व्ही. दॅट इज इक्वल टू 1 इंटू व्ही मायनस डब्ल्यू. what will be total 3 u minus v u minus w आणि याची व्हॅल्यू काय येणार आहे 1 इंटू व्ही मायनस डब्ल्यू व्ही मायनस डब्ल्यू. therefore Jacobian of denominator is 3u minus v v minus w आणि हे लिहिताना मी w minus u लिहितो with minus sign here. w minus u लिहितो. therefore Jacobian of u v w with respect to x y z is equal to minus 1 cube n by d, that is equal to minus of minus 6 by minus 3 into numerator x minus y, y minus z, z minus x, z minus x divided by u minus v, v minus w and w minus u. That gives you answer as minus 2 times x minus y, y minus z and z minus x whole divided by u minus v, v minus w and w minus u. This is our answer. Now we'll go to another example on Jacobians. Students, if suppose u equal to x upon 1 minus r square raised to half, v equal to y upon 1 minus r square raised to half, and w equal to z upon 1 minus r square raised to half, where r square is equal to x square plus y square plus z square. Show that Jacobian of UVW with respect to xyz equals to 1 by 1 minus r square raised to 5 by 2. 1 minus r square raised to 5 by 2. What is given? First thing, u, we call this as f1 equal to u into root of 1 minus r square minus x equal to 0, f2 as equal to v into root of 1 minus r square minus y equal to 0, and f3 is written as w root of 1 minus r square minus z equals to 0. We are going to write these equations in this form. Now simple thing, now Jacobian, इथला न्यूमरेटर काय लिहायचं आहे, डिनोमिनेटर आधी सोपा आहे, काढून टाकू आपण. What will be the denominator? Jacobian of f1, f2, f3 with respect to u, v, w, that is equal to, you can see that derivative of f1 with respect to u is root of 1 minus x r square. With respect to v and z, w, derivative of f1 with respect to u is 0, but with respect to e is 1 minus r square, and with respect to w is 0. Similarly, for f3, with respect to u is 0, with respect to v is 0, and with respect to w is 1 minus r square, and therefore this Jacobian is equal to root of 1 minus r square raised to 3. Root of 1 minus r square raised to 3. Now we'll go to the Jacobian of numerator. Numerator साठी काय लागेल आपल्याला, what is dA by f1 by dA by x equal to, now keeping in mind r square is equal to x square plus y square plus z square, therefore u divided by 2 root of 1 minus r square into derivative of 1 minus r square is, derivative of 1 minus r square with respect to x is minus 2x and minus 1. How it is? Why it is minus? Because minus r square is same as minus x square minus y square minus z square, and therefore its derivative of this term is minus 2x. Because of this, derivative of this root is 1 by 1 minus r square, and derivative of 1 minus r square, once the derivative 0 and derivative of r square with respect to x is 2x is there. On the same line, you can write dA by f1 by dA by y is equal to minus y u upon root of 1 minus y square r square, sorry, कारण हे 2 to get cancel आणि पुढे -1 येणार नाही, इथे x आहे पण इथे y नाही z नाही, त्यामुळे dA by f1 by dA by y, dA by f1 by dA by z will be equal to minus zu root of 1 minus r square is there. 1 minus r square is there. On the same line, dA by f by dA by x equal to minus xv by root of 1 minus r square, dA by f2 by dA by y will be equal to minus yv by root of 1 minus r square minus 1 daba f2 by daba z equal to minus zv by root of 1 minus r square, and daba f3 by daba x equal to minus xw by root of 1 minus r square. Daba f3 by daba y is equal to minus yw by root of 1 minus r square, and daba f3 by daba z equal to minus zw by root of 1 minus r square minus 1. And you can write Jacobian of numerator. Jacobian of numerator as n daba f1 f2 f3 with respect to x y z equal to, you can see that here you can write minus xu minus root of 1 minus r square minus yu minus zu. Similarly, minus xv minus yv minus root of 1 minus r square and minus zv. Similarly here, minus xw minus yw minus zw minus root of 1 minus r square, and denominator we have taken out as 1 upon 1 minus r square raised to root of 1 minus r square raised to 3 is taken outside. Actually here, right here, okay, that is written in that way, and go on solving, we get 1 upon 1 minus r square root of raised to 3 into, upon simplifying all that terms and solving into this determinant, after solving actual cross multiplication etc., or even you can take x common, y common, z common, u common, v common, w common etc., and after upon solving you can get that as equal to minus 1 upon root of 1 minus r square raised to 2. 1 minus r square raised to 2. And finally, Jacobian is equal to minus 1 cube n divided by d. That is minus of and because of minus it become plus 1 upon root of 1 minus r square divided by root of 1 minus r square cube, and therefore it is equal to 1 upon, what will be that? 1 upon root of 1 minus r square raised to 5, or that is 1 minus r square raised to minus 5 by 2, and this is our final answer. Okay. Okay, that much is some we have seen in this lecture. Thank you very much. I will provide notes on this for you. Fully solved examples are there. You can see that. Thank you very much. This is, I am using this mic first time. Thank you.